Hi all. So in today's class we are continuing. We are going to question number 33 in the question paper. So those who haven't watched the previous video, please go back and watch that video where we have already discussed about question number 30, 31 and 32, which are MCQ questions, and the last one is assertion reason question. So let's start the class. As per the model question paper, question number 33 will be usually from the light chapter and question number 34 will be from electricity chapter. So let's see question number 33. A ray of light falls normally on a surface of transparent glass slab. Draw a ray diagram to show its path and also mark angle of incidence and angle of emergence. So first of all, let's draw that one. We know if this is the glass slab, if a ray of light is coming and falling, it will usually fall like this and it will bend towards the normal. Then from here, it will bend away from the normal. Here it's coming from rarer to denser medium. Here it's coming from denser to rarer medium. That's why it is happening. In the previous video also, we have discussed one similar question. But here, the case is slightly different. When we think of glass slab, automatically this picture will come to our mind. But here it is different. See, a ray of light falls normally, which means the ray of light is falling through or it's coming through the normal. So, if this is the glass slab, then if this is the normal, then the ray of light is coming through the normal. We know when a ray of light comes through the normal, it will not deviate. It will not show any deflection. Rather, it will just pass through the normal itself. So, it will just come like this. We know the angle of incidence is the angle made between the normal and the incident ray. So, here, since the ray is coming through the normal, there is no angle. The angle here is angle of incidence is 0 degree. Same way, when it is coming out, it's coming through the normal. So here, angle made between normal and the emergent ray is 0. So angle of emergence is also 0 degree. I hope the reason is clear. Now, next one is arrange the following media in the order of increasing velocity of light. Given the refractive index of air, glass, kerosene, diamond. So refractive index of air is given here. I'll write A. Glass is given here. Then kerosene is given here. And diamond is given here. Okay. So to do this, we should be knowing a relation. That is N. Refractive index is equal to C by V. This is speed of light in vacuum or air. And this is the speed of light in the given medium. So here N is equal to C by V. Let's see. There is, when we analyze this equation, we will come to know that N refractive index is inversely proportional to the speed of light in the medium. So here they have also given us velocity of light and the refractive index. We know they are inversely proportional. And they are asking us to arrange them in the order of increasing velocity. So velocity, smaller velocity should be written first, at last the bigger velocity. So since when we look here, we can understand that the refractive index and velocity are inversely proportional. So when refractive index increases, velocity decreases. And when refractive index decreases, velocity increases. Here we have to write everything in the increasing order of velocity. Smaller velocity first, bigger velocity last. So if we have to write the smaller velocity first, we should select the bigger refractive index first. So let's write the refractive index in the order, that is decreasing order, bigger to smaller. So we'll get the velocity in the increasing order. Let's write. So refractive index, the bigger refractive index is 2.42. Then the next one is 1.5. Then the next one is 1.44. And the last one is 1. So 2.42 stands for diamond. Then 1.5 is glass. Then 1.44 is kerosene. And 1 is air. So now the order of So now the increasing order of velocity will be like this: diamond, glass, kerosene and air. So just keep in your mind that the refractive index is inversely proportional to velocity. They have given the refractive index here. So when we arrange the refractive index in decreasing order, we'll get the velocity in increasing order. That's the idea here. Hope it is clear. We'll go to the next question. In this question, a ray of light falls normally on the surface. The first question is same. The first question is same as what we have done just now. So we'll go to the second part of the question. B part. Light enters from air to glass. So light is entering from air to glass. Okay, so this is air and this is glass. Light is entering. So glass is having a refractive index of 1.5. What is the speed of light in the glass? So what will be its speed here? Speed of light in vacuum is given. That is, usually we'll represent the speed of light in vacuum using the letter C, small letter c. So c is equal to 3 into 10 raised to 8 meter per second. This is already given there. So let's see the relation. The relation, we have already told what is the relation. We know n is equal to c by v. Let's substitute the values. So n, refractive index, n value is already given here. That is 1.5 is equal to c. C value is also given here. 3 into 10 raised to 8 divided by v. So if you just interchange v and 1.5, I can write it like v is equal to 3 into 10 raised to 8 divided by 1.5. You know, 1.5 goes 2 times in 3. So the answer will be v is equal to 2 into 10 raised to 8 meter per second. Usually when we say the question like this, we'll be confused and we might think like, okay, I won't be able to get the answer. So there is possibility for us to skip the question. But usually they'll give us simple values like this, which we'll be able to solve in very little time. So please don't skip these kinds of question. Just attend it. The only relation is n is equal to c by v. This happens when the light is entering from air to any medium. Please keep in your mind. We'll go to the next question. This question is, name the factors on which brightness of image in a camera depends and how. It's a general question. It's from the light chapter. Name the factors on which brightness of image in a camera depends and how. So these are the factors on which the brightness will depend. It depends upon the aperture. Aperture, we already know what is aperture in the case of lens or mirror. So this length from top to bottom, if it is a mirror or if it is a lens, this is the aperture, this length. So when the aperture is high, when we have more aperture, more light will enter. So we'll get a clear image, a bright image. So when aperture increases, the brightness increases. Again, amount of light falling on the object. Object will be in front of the camera. So if there is more light there falling on the object, that light will get reflected back and we'll be able to see more. So when the amount of light is more, the object will be more visible. There will be more brightness. Again, distance of the object from the camera. If the object is very much far away, then it won't be that much bright. When the object is very much close to the camera, it will be bright. So when the distance increases, the brightness decreases. It's opposite, inversely proportional. Now, focal length of the lens. When the focal length is more, when the focal length increases, then the brightness will decrease. When the focal length is more, we have to focus far away, then the same thing happens. The brightness will be less. Coming to exposure time, how long are we exposing it? How long is the light entering the camera? If more time is given, if more exposure is given, then more brightness will be there for the image. So these three factors, when the aperture increases, brightness increases. When the amount of light falling on the object increases, again the brightness increases. Then when the exposure time increases, again the brightness increases. But when the focal length increases and the distance of the object increases, the brightness will decrease. These are the points. Please do understand that. We'll go to the next one. Draw a ray diagram showing the path of rays of light when it enters with oblique incidence from air to water. Earlier we saw a question where the light is coming normally. So here it's coming obliquely. It's making some angle with the medium. So let's see, first it is coming from air to water. Here we should be knowing that air is optically less denser than water, or water is more denser than air. It's optically more denser. Now from water to air also, when we know this concept, we'll be able to do it. Let's see. So first of all, let's consider this as air, and here I have water. Let me show this water like this. This is the place where I have water. So here the light is entering like this. Instead of going in a straight path like this, it will bend towards the normal because it's a denser medium. Okay. Now, in the second case, they are asking us what will happen when the ray of light is coming out of the water. So now it is going like this. Here we have the normal. So here it should actually go like this. Instead of going like that, it will go away from the normal because it's coming from denser to rarer medium. Just show these two. That's enough. So please understand that when the light enters from a rarer medium like air to water, it will bend towards the normal. When it comes from a denser medium to rarer medium, it will go away from the normal. That's it. This is the point that you should remember here. Then suppose if the ray is coming through the normal, suppose if this is our glass slab or water, and if it is coming through the normal without any deflection, it will go as it is, making a straight line. Okay. We'll go to the next question. Let's see one question from electricity chapter also. Here, a student wound an insulated copper wire around a soft iron rod. He then connected one end to the rheostat and the other free end to the battery via a key. He closed the key and observes the deflection of the magnetic needle in the magnetic needle placed nearby. Now he altered the current using by reversing the connections of battery and again noted the change in deflection of the needle. Okay, so here first question is, why do the student perform this activity? See, what is this activity based on? This activity is based on magnetic effect of electric current. Magnetic effect. It's based on magnetic effect. We know that whenever current is passed through a conducting material, it will behave like a magnet. A magnetic field will be created. This is based on that activity. To prove that activity, he is doing that. Now, what did the student observe? Student observed a deflection. He observed a deflection, which means that a magnetic field is generated. A magnetic field was made when current is passing through a conducting material. Now, comment on the statement, a material in the medium of a current carrying coil gets magnetized. Okay, before that, what did the student observe? We can also say that when he was passing current in a single direction, the magnetic needle showed deflection towards one side. When he reversed the current, the magnetic needle will show deflection in the opposite direction, which means that when the direction of current is changing, direction of magnetic field also changes. Or when the direction of current reverses, the direction of magnetic field also reverses. You can say like that also. Now, last one is comment on the statement, a material in the middle of current carrying coil gets magnetized. This statement is a true statement. It's a correct statement. Where it is saying that a material in the middle of a current carrying coil. We know current carrying coil is usually a solenoid. So when current is passed through solenoid, it behaves like a magnet. So if we keep a soft iron kind of material inside the solenoid, it will become magnetized. This is how electromagnets are made. So the statement is correct. We will be able to write a little about electromagnet, solenoid, what happens inside that, all that. Okay, so this will be the answer for that. So now, as we have seen, this question number 33, which is a 2-mark question, will be mostly asked from the light chapter, and maybe it can be asked from the electricity chapter also. But as per the CBSE's model question paper, they are asking this question number 33, which is the 2-mark question from the light chapter. Let's see the question asked by CBSE in their model question paper as well. Here we have the question. So the question is, the above image shows the formation of an image with an optical instrument. They haven't told us which instrument. identify the optical instrument in the image. So earlier also we have told about converging and diverging lens and mirror. So here the ray of light is coming, hitting here and going far away. This ray is also coming and going far away. See, when we look at this, here it was coming together, earlier it was together in this area, but later they are going away, which means they are diverging. Let's see whether it is a mirror or lens. If it was a mirror, then the ray of light would have gone there, it will strike there and will reflect back. But here there is no reflection. It's passing through the lens or through the material. So when it is passing through, it is usually a lens. It's not a mirror. So it's a diverging lens. Diverging lens is usually concave lens. So here what they have shown is a concave lens. If it was a convex lens, it would have converged here. It might have come to a single point. But here, since it is moving far away, it's a concave lens. So first answer is concave lens. What type of image is formed in this case? You can see the image here. The object is kept here. From the object, two rays of light are going. Then afterwards, they are forming an image here. Looking at the image, we will be able to understand the image is erect image. So it is virtual and erect image. If you look at the size, this one is bigger, this is smaller. So it is diminished image. So it's a virtual, erect and diminished image. Hope you understood that. Here we have an object. So from the object the light ray is going, one more ray is going. After that it's meeting at a particular point here, making a small image. This is also standing on top of the principal axis. We have discussed more about this in the chapter. Those who haven't watched that, please go there and watch it. So this is standing on top of the principal axis, same as the object is. So this is an erect image. So virtual always comes with erect. So it's a virtual and erect image. If it is inverted, then it's real and inverted. So it's virtual, erect. So when we compare the size is small, so it is diminished. That's all. Question number C. Based on the measurements given in the image, calculate the focal length of the instrument. We have to calculate the focal length of this. Okay, let me clear all this, then we'll calculate focal length. Look here. From the diagram, object is kept at 20 centimeter towards the left side. So when it is kept towards the left side, as per sign convention, we should take the object distance as negative. So U is minus 20 centimeter. Now, next one, the image distance V, it is also formed towards the left side. So it also should be negative, minus 10 centimeter. They are asking us to find out the focal length. So focal length F is equal to question mark. This is a lens. Since it is a lens, we have to use lens formula. That is 1 by V minus 1 by U is equal to 1 by F. Now let me substitute the values given here. 1 by V, it is 1 by minus 10 minus 1 by U. 1 by U is minus 20 is equal to 1 by F. Now 1 by minus 10, minus into minus, it will become plus 1 by 20 is equal to 1 by F. Now I'll just interchange both. 1 by 20 minus 1 by 10 is equal to 1 by F. Now if I just multiply 2 here on the numerator and denominator, then I can make it like this. 1 by 20 minus 2 by 20 is equal to 1 by F. So now 1 by 20 minus 2 by 20, it is 1 minus 2 divided by 20 is equal to 1 by F. 1 minus 2 is minus 1 by 20 is equal to 1 by F. When you take the reciprocal, F is equal to minus 20 centimeter. So our focal length is minus 20 centimeter. So the answer is minus 20. Focal length is minus 20. So as we have seen in these questions, question number 33 will be mostly coming from the light chapter. So please do practice well. Now we'll go to question number 34 in the next video, because if we continue it will be a lengthy one. So in the next class we'll be discussing about question number 34. Question number 34 usually come from the electricity chapter, and there will be an optional question as well. So question number 34 will be an OR question where you'll have two options. So in the next video, let's discuss about that. Thank you.